Okay, so we're going to talk about natural log. If you notice, the word log is in there. Now, why is it called natural log? Because, in summary, and I bet your science teacher can say it way better, but natural log is the way that things grow in nature. So if you were to talk about a plant or you were to talk about humans, if you look, they grow at a certain rate and it's very similar. And so when they did that, they realized, oh, okay, it grows at about this base. So what they did is they decided to call that base E. So if you put E to the first in your calculator, this is what would come up. Okay? Whenever we're talking about base E, that's not the log, that's the natural log. So when you see ln, that means natural log. Let me clarify. If you see log 3, that means that's in base 3. But if you see natural log of 9, that's in base E, but it's an imaginary base E. So if I had log 9, that's base 10. If I have natural log of 9, that's base E. These two are inverses of each other, which you will see in a second, okay? So let me show you. If you look here, if this was base E, and I was to change that to exponential form, E to the first does equal E, which in the calculator is 2.71828. So what I wanted to show you is in the calculator, so I graphed in Desmos. Let's see if I can show it. It's kind of hard to see it because the screen isn't making it so. But if you look, I graphed 0.5 e to the x and 0.5 l, natural log to the x. There's the red, there's the blue. If you look over here, they're inverses of each other. Okay? So now we're going to come over here and we're going to just graph, and I just want you to see that when I do this, let me move this over. Okay. And I'm graphing this. This is, I just want you to see, this is e to the x, and this was, let's see, what was the other one? I forgot what it looked like, but it's inverse, yep. Okay. Natural log. And if you look, remember how when we did inverses, we had that reflection line? Okay. I don't even care about this. I just wanted you to see that natural log and base E are inverses of each other. Okay? So obviously if I was to put this in the calculator, you would see, let me put that in the calculator so that you can see it. So let me go back over. If I go, okay, of course, E, and then what you would do is you would go to functions, which you can't see. You would go to miscellaneous, which is natural log, and, oops, I'm doing awesome. Okay, let's try this again. To the functions, miscellaneous, natural log, 3, and the answer is 3. Why is that? Because these two are inverses of each other. So let's go back just so you can see that. I wanted it to make a point in the calculator so you can use that to help you. Okay. But what happens when the little turns big? These cancel each other out, and the answer is 3. Okay? This one, little turns big, 3. This one, when you're adding, what does adding mean? It means you're multiplying. Can I just cross things off? No. It's in base E, but you don't need to show that. It is fully simplified. In this one, the little turns big, and the natural log of E, that's the inverse of each other. Okay? So that turns into times 1, which is 2x. Okay? All the rules that applied for logs apply for natural logs. The only difference is that you're dealing with something called a natural log, what occurs in nature. Okay? So what we're going to do here is we're going to simplify. So let me zoom in, move this down. Okay. So what does it mean when you add? It means you're multiplying. But when you're multiplying exponents, you're really adding them. And then what happens to a little? Turns big. Let me make that look more like a 1 so it doesn't confuse you. And that's the answer fully simplified. And some of you go, but I thought you could cancel. If this was 11 natural log of E, then those are inverses of each other, and the answer would be 11. Only when natural log and E are next to each other. Okay? Let's look at this one. When we have subtraction, what does subtraction mean? Subtraction means divide. Well, when you're dividing, it means more on top or more on bottom. There's more on bottom. Okay? But actually, in this case, we're going to leave it like this. So if I have x to the 4th over x to the 7th, when you subtract, it's x to the negative 3. What happens? Little turns big. And that's my answer simplified. Okay? Just like before when we had logs, like if you had 3 log of x equals 12, which you can't see, the first thing you would do is divide by 3, right? So guess what you do here? Divide by 3. E to the x equals 4. Now if you were left with log x, which probably wouldn't be, equals 4, what would I ask you to do? Change it to exponential form. Well, this is an exponential form, so I can't change it to log form. I take the natural log. So whenever you see base E, natural log is in your future. That cancels, little turns big. X equals the natural log of 4. And then I pick up my simple calculator because that's all I'm going to have access to. Natural log is right underneath here of 4. 1.39. So x equals 1.39. All right, let's go to the next one. I solve. What's the first thing I do? Subtract 6. Divide by negative 2, just like we've solved before. That's all I can do now. It's an exponential form. I can't find x, so I have to change it to log form. But it's in base E, so I'm not taking the log of both sides. I take the natural log of both sides. That cancels. X equals the natural log of 15. Pick up my calculator. 2.71. Now I want to point out, how do you know I'm right? I could plug 2.71 in, go 6 minus 2 times. Now here's the problem. If you go like this in your calculator and E, let's see. Oh, by the way, where is E? So natural log E. So you would go second E to the 2.71. And it should equal negative 24. It's negative 24.05. But I bet you would agree, this is negative $24. This is negative $24.05. That's really close. So you did it right. All right, what do I do when I have a fraction? Multiply by the reciprocal. So I'm left with e to the 4x equals 9. Nothing else I can do now. Natural log both sides. What happens? Cancel. 4x equals the natural log of 9. And then I divide both sides by 4. So x equals, so I'm going to plug this into my calculator. The natural log of 9 divided by 4. 0.55. Okay. Let's do the next one. Subtract 5. Just like we normally would. Divide by 2. Now what do? Natural log. This cancels each other out. X minus 1 equals the natural log of 1/2. And whatever value that is, I'm going to add 1. So I'm going to go the natural log of 0.5 plus 1. And I get 31 cents, or 31 hundredths if I'm going to be fancy. Okay, let's go to the next one. When the bases are the same, remember when we had like 3 to the x equals 3 to the x minus 5, and you go, oh, the bases are the same, just set that equal to each other? Well, look, the bases are the same. So, just set this equal to each other. 4x minus 3 equals 9x plus 1, 5x equals negative 4, x equals negative 4/5. I'm actually going to jump down to this one because it's convenient. All right, what does subtraction mean? Subtraction means divide. I can divide that. All right, so before, when we were in base E, we natural logged both sides. This time, we're in natural log, so we're going to change it to exponential form. So you go e squared equals 4x, and then you divide by 4. So I'm going to take this and put it in the calculator. So I go second natural log, I get e squared, it's a value, divided by 4. And I get 185. Oops. How do you know I'm right? You can plug it in, blah, blah, blah. Okay? I'm going to jump over to this one because I don't have very much space for that one right now. So, what do I do when it's adding? When it's adding, it means multiply. Distribute, distribute. Some of you go, why is she keeping it in parentheses? Because this whole thing is being natural logged. Now it starts with natural log. All right, that reminds me, it's in base E. Change it to exponential form. So now I have e squared equals 3 to the x plus 12. I could figure out what e squared is right now. Some of you might want to do that. So second e squared, and I get 739. So 739 equals 3x plus 12. Subtract 12. Okay. Negative 461 equals 3x. Divide by 3. And I get x equals negative 1.54. Okay? Make sure you see that dot. Now I don't know if you noticed, but the bottom half by accident, it's literally the exact same problem. So you don't need to do them again. But I forgot this problem here because there wasn't really space. So I'm just going to do it down here, okay? Let me erase this, make it bigger. All right. What do I do when it's adding? Adding means multiply. Now there's nothing else I can do. It's in base E. Change it to exponential form. E to the first equals 3x. Divide by 3. So I'm going to put that in my calculator. So second e to the first divided by 3. And it's 91 cents. Or if I'm going to be fancy, which I should, 91 hundredths. Make sure that you're doing all your IXLs, okay? Because if you'll notice, there aren't really any worksheets. I don't think. Let me just double check. Well, if I turn the page, nope, because that's what you did yesterday.